Now we look at greenhouse gases. There's basically two categories of greenhouse gases. We have naturally occurring elements and we have synthetic elements. So there's effectively three naturally occurring elements that we really care about: carbon dioxide, methane, and nitrous oxide. Then the other three synthetic elements that really don't affect us are sulfur hexafluoride, fluorofluorocarbons, and hydrofluorocarbons. And these are the gases that we designed and used to replace the ozone depleting gases. So now they're not putting a hole in the ozone, but they're heating the atmosphere. But they're not significant in concentration. So they come up with a common denominator, and that's a global warming potential. And so carbon becomes the baseline of 1, and everything else in relationship to its heating value, let's say in the atmosphere, is compared to that baseline of 1. So methane is at least in the IPCC standards, 21 times stronger than carbon dioxide in its ability to radiate heat in the atmosphere. It's actually been proven to be higher, but for consistency in the reports, we'll leave it at 21. And then nitrous oxide at 310 times the concentration. And when we get into some of the synthetics, you can see they're 11,000 times stronger, 23,000 times stronger, but they're not in significant quantity. So when we look at all of the greenhouse gases that are emitted by estimate from the EPA, and we say, well, how do they break down into those two key areas, the naturally occurring gases and the synthesized gases? And the dark area shows you that the bulk of the concentration is carbon dioxide, and the second level is methane in the gray. And then we can see nitrous oxide being third, and then all of the synthesized gases have this narrow bar at the top. And a lot of that's from semiconductor manufacturing. So here's the formula to equate everything in a single common denominator, right? They're using teragrams, or each unit is 1 million metric tons, teragrams of carbon dioxide equivalency, right? We'll equate all those gases. So it's a fairly simple formula. We have to start with gigagrams of the gas times the global warming potential, and then we convert that to teragrams, or units of a million metric tons. So when we look at that chart again, what stands out with methane is its short atmospheric lifetime. So in theory, if the science is correct, and we stopped 100% of CO2 emissions because of its atmospheric lifetime, in theory for the next 50 to 200 years, the temperature could keep rising independent of what the emissions are because it stays with us. Whereas with methane, the atmospheric lifetime is 12 years plus or minus 3. So it tends to, if we look at the automotive side where they focused on diesel particulates, or what they call aerosols, they have a very short atmospheric lifetime. And I believe that's one reason why they concentrate on them, because they can make a difference in local air quality with regard to pollution. Well, with regard to greenhouse gas emissions, because of the short atmospheric lifetime, methane has a similar characteristic. And unfortunately, that's the largest constituent of what we transport and combust, is methane. So it's at least 21 times stronger and probably closer to 25 times stronger than CO2, and it has a short atmospheric lifetime. So now we take the EPA's report and we look at all of the key industries that comprise all of the greenhouse gas emissions. And I just highlighted in yellow industries that we participate in, right? And we see that I'm going to have to read off the screen. Emissions from stationary combustion, which is predominantly the combustion of natural gas in power generation, but also some of the combustion activities that takes place in compression. And then we see the second one is emissions from non-energy use of fuels. And we go through and we highlight where the natural gas community is with regard to this. Then we just look at CO2 here as a percentage of all the emissions, and not the carbon dioxide equivalency of all the greenhouse gases, but just CO2 within that. And natural gas is in the top 5. And that's from the natural occurring portion of CO2 that is inherent with natural gas. And then we see petroleum production and petroleum systems, and both of those include some wellhead activity, because it's hard to separate the natural gas and the oil at that point. So now we say, okay, well, what are those CO2 emissions, and how do they break down? And this is from 1990 to 2007, and it's estimated, right? And we've never measured greenhouse gas We use formulas to estimate it based on what we're transporting, what we're burning as fuel. And we can see for CO2, the bulk of the estimated emissions the EPA puts out really is in the gathering and processing segment. And at the E&P side, that with regard to transmission and storage, it's not significant for just that element. So then we look at methane and say, okay, well, methane's only about 8% of all the greenhouse gases, but we are moving up in the chart from 5 to 3. So we make the list on CO2, and we make the list on methane, and we make several parts of the list with regard to all greenhouse gases. So, if we look at enteric fermentation, which is basically feedlots and landfills, I really believe these are easy issues to remedy based on just changing practice. So it's a little bit harder for us to change the practice of compression and pipeline transmission. So now we look at how the methane breaks down in the report, also in carbon dioxide equivalency. And now it's a more equal distribution with some of what was in gathering bumping up into distribution. So across the full range, when we transport natural gas, even when we distribute it to people's homes at low pressure, we're seeing that methane is part of the emissions. So when we look at nitrous oxide, we don't even show up on the list, although it's not insignificant with regard to its role in pollution. When we look at greenhouse gases in quantity, nitrous oxide really doesn't even show up for what we're doing. So how does carbon become currency? Why is it different? So we look at the first fact that they're equating everything in terms of carbon and its global warming potential. So they have a mathematical formula of making everything common. What they didn't put in the report was the value of that carbon. So when we look at the history, the world's largest carbon market, the European Union's emissions trading scheme, we see that the December futures, which I think is a good indication of where the price of carbon is trading on average about $21.50 when we transfer it from euro to dollars. So if we look at a teragram is 1 million metric tons, and we look at the price of $21.50 is what a metric ton is going for on the EUETS, we see that at 1 unit in this report is worth about $21.5 million. So now we should probably look at those fossil fuel flows in terms of the monetary value that's transpiring in the proposed greenhouse gas legislation. So we go back to the CO2 emissions that we captured from the report, and we picked 2005 values because the American Clean Energy and Security Act, or House Bill 2454, is stating a reduction below 2005 levels. So there's no credit for the 14% that we've reduced below 1990 levels to date. We're going to go below 2005 levels. That's what the coal lobby's been able to achieve because their emissions are better, you know. So now we look at CH4, and then what I had shared in transportation, because that element of transportation, you can see when we pull that out, the bulk of the gas used in transportation here is, you know, almost all going to the pipeline, and it's just negligible. It almost makes 1 unit for buses. That's where most of the natural gas. So we're not really using natural gas in transportation. It's what we're consuming. And then there were additional things I pulled out of the EPA's report. There are enhanced recovery techniques we use where we're using the CO2. So when we do acid recovery and there's naturally occurring CO2, so that needed to be included. Also, when we look at some of the fugitives effectively that aren't included in the initial reporting, that is estimated here as well. And then there's also some of that activity in CO2 in the field, albeit pretty small. And then there was some petrochemical production that produced some greenhouse gases as well. So when we add all those up, from the EPA's report, we get 235.6 teragrams of carbon dioxide equivalency of the total industry carbon footprint. So we have to understand what the value of the carbon footprint is because that's what they're going to cap. And they're going to use transparency, right, if we look at RGGI. So even if they give those certificates away, the transparency says the value of the carbon must go through to the end market. So they're plainly stating that the cost of electricity in those 10 Northeast states is going to go up, and then the counter to that argument is well, we're going to take some of the $430 million we've received in selling these credits over the first year, and we're going to use that to have a public campaign on energy efficiency. And so people will use the electricity more efficiently, and ultimately, since they use less, even though the price goes up, they're not going to pay anything. But the price has to go up for the trading scheme to work. If they don't assign a price to carbon, then there's no capturing of what they would call the total cost of fossil fuel consumption, and there's no incentive for some of the alternative technologies. But it really appears to be financial. So we get the whole value based on current dollars of carbon of about $5 billion. So that's what the carbon footprint's worth. And then we look at what's in House Bill 2454 and we say, okay, a proposed 3% reduction over 2005 levels by 2012, which is just 2 years away. And so we say, okay, that 3% is worth about $151 million if we had to buy the credits and we couldn't reduce 3%. The 17%, is worth about $860 million that we have to achieve in 2020 on current dollars. The 42% reduction is $2 billion, up to the 83% reduction in 2050. It's almost the entire value of the carbon footprint. So there's a monetary unit that never existed. Compliance activity wasn't assigned a value. Compliance activity didn't have an incentive, and so I think rather than mitigating, we're probably going to have to embrace whatever the final legislation is to try to drive through those numbers, because a 3% reduction, if we just meet it, we lose the opportunity to bank any difference. If in that example of getting to 2 grams NOx you could get to 1, or if it's 1 and you get to a half, because Chad's in the room, there's value in that now. So if we drive through the minimum standard, there is incentive for us to bank credits pending on what the final legislation is. So it's really irrelevant what we think of the science. There's a financial mechanism that's been playing out since the 90s on this, and it's established at an international level. So now I take the entire energy section, because that was that tan area we're looking at, and let's say it's 6,100 or 6.1 teragrams of CO2 equivalent, and we run the number on that. And so it's not preposterous that you hear the NRDC making statements that the carbon will be a $60 to $120 billion market. When we take the number of teragrams the EPA estimates times the current value, the carbon footprint of energy in the United States is $132 billion. And so a 3% reduction on 2012 is almost $4 billion in credits, or in activity, a 20 or a 17 to 20% reduction, depending on how it goes through the Senate, by 2020, it's $22 billion, all the way up to 2050. So it's significant, the value that they're assigning to carbon and what it represents. So I picked this quote from Truman because I thought it was very interesting. And Truman said, the only thing new in the world is the history you don't know. And we have this really interesting feedback loop that's happening. The history we don't know is what the actual emissions were in 2005. But as the 2009 legislation is passed that we have to report, and monitor and report our greenhouse gases, we're going to learn about that history we don't know. And if you look at some of the accuracy percentages of some of the estimations, it could be off by 20%, which would work for us, or it could be off against us by 130%. So when we start monitoring, and when they include fugitives as well, we could find out a lot about the history we don't know. So it's the history we don't know that's going to create the future that we don't have. I mean, it's a very interesting feedback loop, because we're talking about estimated numbers from 2005 that we're going to reduce, and then as we go forward, that feedback loop is going to play a role.